No, Elon, thanks. But you're the better technologist. Oh, Muskie, you're too kind. Oh, hey, sorry, didn't see you there. What's up, nerds? Harbinger here. I'm going to do video number 2 of a 2-part special. That special being loops with inside loops. So, nested loops. You saw the graphical version already. We did the drawing video in which we were drawing cool repeated designs using Turtle Graphics and Python. This video is going to focus on the theoretical component, which is loops within loops using the AP Computer Science principles syntax. If you haven't seen video 1 yet, you probably want to go back and watch it. Some of these things are easier seen with pictures that we draw, as opposed to some like weird notation on, I was going to say paper, but I guess like the computer screen. And if you want to watch this video completely independently, hey, you know, I get that. I like people who don't follow the rules sometimes too. So I'm going to do something really nice, and then I'm going to make it worse, and then I'm going to make it worse, and then I'm going to make it worse. So we're all good at something, and my thing in life is making situations worse for people. You know, it's a gift, I'd like to think, you know, and not only is it a gift, I've developed it through years of practice. So here goes. So I'm going to like wave the magic wand and say the magic words, a la peanut butter sandwiches. Poof. Took 2 tries, but you know. So I've got that. I'm going to use the AP syntax just because I think it's important that we practice for that, and you're going to see it on the Delta Math stuff, and I got to make sure that we are ready for it. So I'm supposed to ask something teachery here, like, hey, how many times do you think that $ is displayed? And my hope is that you're saying it out loud. Hey, 7 times I'm going to draw 4 $. And they're vertically stacked, so it's like dollar, then dollar, then dollar, then dollar. And I'm going to do that a total of 7 times. So I hope you know that it's a multiplying thing, right? 7 times 4 is 28. And then if I really want to make it fun, what I could do is like demarcate it. So now it's 4 $, then a series of hyphens, then 4 $, then a series of hyphens. And so we have like 7 chunks of $4 each. So maybe it's easier to see. If you were doing this in Python, you know, it might look something like for x in range 7, for y in range 4, print dollar bill, y'all. Like that. So this is AP style syntax. This is Python syntax. But I'm going to delete the Python thing because I really don't want people to think that I'm leaning on Python way too much. I really feel like in order to test prep, I really care about the ideas here. So these are equivalent. One's just an actual language and one is like fabricated syntax. Isn't the Python thing man-made too? Yeah, but you know, the other one's more conceptual and I care about the concept. So how do I make that better / worse? I know. I'm going to declare a variable, and I'm going to have the bounds be of variable bounds. So I'm going to cordon it off right there, as long as you know that I'm, you know, doing different stuff here. So I've got a variable called x. Ooh. Harbinger learned to declare variables. What's up? You know, I got that one going on. So I'm going to use repeat until loops, and I'll show you why in a second. And I'm going to repeat. If I really wanted, I could do this like with a 4 next, but I don't want to. You know, I want to do this differently. So it's not going to be the same exact thing as what you see above, but it's going to be slightly worse. So I'm not going to repeat until. This one's actually going to be repeat x times. So you might be surprised. I actually took notes on what I'm doing today so I could kind of follow along and not look as dumb. I'm still going to look dumb, but, you know, this minimizes the dumbness. Which, you know, not the worst thing in the world. So right now, and this is incomplete, before you're yelling, I'm missing a line. I know I'm missing the line. We'll talk about it, though. Hey, 1 is x. And I'm going to keep going until x is 7. So is 1 7 yet? No. So I'm going to repeat one time. One time, display a dollar sign. Hey, the loop is over, right? Just repeat once, and then draw the horizontal line. Now is where my next part comes in. X. We can't forget to increment the variable. So x is now 2. Is 2 equal to 7? No. But I'm going to repeat twice. Dollar sign, horizontal line. X is now 3. Is 3 equal to 7? It is not. So let's repeat it 3 times. Dollar sign, horizontal line. So right now I've got $1 and a horizontal line, $2 horizontal line, $3 horizontal line. Now $4 horizontal line, $5 horizontal line. I get up to x is 6. 6 times dollar sign, horizontal line. And this says down here, hey, 6 plus 1, 7, gets stored in x. Is 7 equal to 7? Yes. So I'm not going to do the interior of the loop, which means I had $1 sign, then 2, then 3, then 4, then 5, then 6, and it's done. Right? So some people think there's $7 signs at the end, and there's not. There's 6. So we got to be really careful about that. But what's really neat is it's almost like pyramid in a sense, because it's 1, then 2, then 3, then 4, then 5, then 6. So we're adding more dollar signs on every single time, and that's kind of neat. So I'm going to demarcate it again, show you that the next thing is slightly different. So my last pair of programs is kind of complex. And there are things in computer science that are like watershed moments. You know, there are rites of passage. And one of them is the thing I'm about to do. It's not a formal programming class, so it's not being formally assigned, right? If this was Java, or if this was C++, or Visual Basic, or any other thing, I'm probably assigning this as a formal lab, because then I can base a whole lot of things on it, and I can test this, and so many people, like, it's almost like Hello World. Like, every programmer starts with Hello World, and then after you print Hello World, there are other fundamental programs you have to write. There's not many of them, and this is one of them. So I'm going to write a prime tester. I'm going to tell if a number is prime or not. And if you remember prime numbers have 2 factors. They have 1 and themselves. 11 is prime because 1 is a factor of 11. 11 is a factor of 11, and nothing else in between. There are 0 factors between 1 and 11 for 11. 12 is not prime. 12 is composite. Because between 1 and 12, there's 2, 3, 4, and 6. So you can either count factors from 1 up to the number, and hopefully you have 2. You can count the factors between 1 and the number, and hopefully you have 0. But that's the approach I'm going to take because it's 2 steps faster, and I value efficiency. So here we go. I'm also going to use AP-style syntax. So if you don't like it, you better get more comfortable with it. So I'm going to input a number, and I'm going to store it in a variable called num. So maybe they tell me 13. Maybe they tell me 1300. Maybe they tell me 1313. I don't know. Whatever they tell me, I'm going to store it in num. I almost prefer not to know what the number is because then I have to prepare for like a general case, right? So some people say, well, if 2 is a factor of it, I know it's not prime. And then they write code for if 3 is a factor of it, if 4 is a factor of it, 5 is a factor of it. And they just, every single factor they can think of becomes like an if statement. And what if your number that you're checking its primality is a product of 2 really large prime numbers, right? No matter what numbers you write code for, there's always a bigger prime. And there's a bigger prime than that, and we can multiply them and get something gargantuan. And then your code would fail. So we have to kind of prepare a more general case. And if you're wondering, like there's always a bigger fish from episode 1, they kind of use this idea in cybersecurity, and we're going to get to that later on. So just keep that in the back of your head, like the functionality of large prime numbers. So I need other things too, right? So what I'm going to do is I'm going to declare a variable called FC that stands for factor count. I just don't want to write factor count over and over and over. And for me, I'm going to check to see how many factors a number has. Because hopefully it has 0. I'm not looking from 1 up to it. I'm looking from 2 up to 1 less than it. because, like I said, it's 2 steps faster, and it saves me some time. I also need a variable to represent what number I'm checking currently. If I want to know if the number 79 is prime or not, it is. But I would check to see if 2 goes into it, if 3 goes into it, 4, 5, 6, 7, 8, 9, 10. So I need a variable that represents which one am I checking right now, which potential factor. And I could call it potential factor, but that's a lot of writing. So I'm going to call it step. And I'm sure people are like, how come you can't use X or I or whatever? I can. I want step. It's a step variable. And I'm starting it at 2 because why would I bother with 1? Like, I know 1 is a factor of the number. I don't want to check if 1 is a factor of num because I already know that it is. So step starts at 2 for me, and that's okay. Okay, to quote Anakin, this is where the fun begins. I'm going to repeat until step equals num. So step starts off at 2, and it's going to jump in a minute to 3, and then 4, and then 5, and then 6, and then 7, and it's going to keep climbing until I hit the number I'm checking. So my goal, I guess, is to like bring it up slowly. And if you're really good with math, you might know I don't actually need to bring it all the way up to the number itself. There's actually a stopping point in the middle somewhere that I don't have to keep going past. That makes my code even more efficient. But hey, I'm teaching for beginners right now too, and I don't want to mess with like upper bounds of primality check functions. So here goes. We haven't done ifs yet, but I'm going to use it. If the number I'm checking right now is a factor of the number that I want to know if it's prime or not, we got to do something. So I'm checking num, and if you don't know, I want to see if 2 is a factor of 79 or something. So the only way to really do that nicely is if 2 divides into 79 nicely and doesn't leave a remainder. So if 79 mod 2 is 0, I know 2 is a factor. But it's not. So then I'm going to check if 3 is a factor. Is 79 mod 3, 79 mod 4, 79 mod 5. So I have to keep this mod process going. Like that. And if it is, I increment factor, which means I add 1 to the factor count. Now, a lot of people are probably yelling at no one's actually yelling at the video, so I keep saying that. A lot of people are probably thinking at home like, well, if you found a factor between 2 and it, couldn't you just stop? You're like, hey, why keep checking? You found one. Yeah, but I don't really have like a break function in this, if you know any kind of Java or something like that. I don't have a nice way, and if I structured my loop check carefully, I could be doing something like that, but I'm teaching for beginners. So it's okay to check from 2 up to 1 less than the number and not really lose sleep over it. I just gave a speech about being more efficient, and here I am being inefficient. So deal with it. It's inconsistency. So, hey, if step is a factor of num, if num is a multiple of step, let's increment factor count. Hey, I found one, right? And I can't forget step has to increment. Otherwise, I'm going to keep checking 2. It's not very fun. And I'm going to keep checking 2 forever. So what this does is the code goes from 2 up to 1 less than the number, and I count all the factors. So if I were to check something like 75, 2 is not a factor, but 3 is, and 5 is, and 15 is, and 25 is, and so factor count would be 4, and now I got to deal with it. So I don't have to indent this anymore. If FC equals 0, let me tell you, if the factor count was 0, it was prime. Or prime, one of the two, And then if you don't know about loop syntax, conditional syntax, else just means like otherwise. So if FC was 0, it's prime, otherwise it's not. So I'm going to say it's composite. You learned the word in middle school, so we might as well use it. Composite means not prime. So this is my prime checker. It's done. There's nothing else I really need for it. So if I were to say it out loud, if I were to check something like 83, number please, 83. Okay, FC is 0 and step is 2. Is 2 equal to 83? It's not. So let's do the loop contents. Is 83 mod 2 0? No. Is 83 mod... Sorry, so I increment step. is 83 mod 30? No. So I increment step. Is 83 mod 40, 83 mod 50. So I'm going to keep checking all these mods, and I'm going to increment factor count or not, as appropriate. And when I'm done, I'll finally have climbed up to the number I'm checking, and then I have to check if my factor count's still 0 or not. So that's not awful. I want to make one last adjustment, though, to make it awful. And I'm going to copy all of this so I can leave this set of notes intact and make a bigger version down below. Okay. My last thing on this one would be, what if I want to display every prime number from like 1 to a million? So maybe some people are thinking like, okay, so 1, I understand that. Maybe 2, maybe I'll start checking at 2, maybe 3 or 4. But if you're doing this by hand, you're constantly resetting variables and you are checking factors and checking factor count, and oh my gosh, that's a lot, right? So it starts off small, and then we make it really big, and now I'm going to check something all the way up to a million. So I better do something about it. So I'm going to run a loop, and it's going to say the number I'm checking. So num, I don't even know what, not num, because I already used num. So like fin, it's like my final thing. A million. And instead of num, I'm going to do, let me think, whatever number I'm on, I guess. I'm going to start off checking 2. Is 2 prime? You know what? We already know 2 prime. I'm going to start off with 3, even though we know that 2. And that's cool. Factor count 0, step still 2. I need a loop, though. So repeat a million times. Let's see. I reset my variables. Every single time now, I'm going to check if I'm just indenting because this is all kind of like consequential on the line above it. So repeat a million times. Hey, the number I'm checking currently, let's see, maybe that's not what I want. I'm going to start off checking 3. Maybe I don't need num after all. And I would love to be smart for like a day, right? I took notes and then I was like, oh, I could do the last one. I'll just, do without the notes. That's better. Hey, repeat until. There we go. Hey, repeat until num equals a million. So it starts off at 3, and I'm going to check every number from 3 to a million. And when I check 3, let's see, I have a factor count of 0, step is 2, and repeat until step equals num. So is the number I'm on maybe not 3, maybe like 102, maybe 15,000. Is 15,000 mod 2, 0? Yeah. So increment factor count. And then no matter what, I'm going to increment step count. And eventually, I'm going to do this check when all the loop is done. And after this inner loop checks finishing, whether or not that particular number that I'm on right now is prime, that's going to reset these guys and bump it back up. All I have to do is at the very end, increase the num value. There. Now it's going to climb up and climb up and climb up until I can hit a million. So I don't know how to concatenate text. You know what that means? It means take 2 pieces of text and join them together. I don't think there's an AP criteria for that. I could be wrong. But this looks like it makes sense. So I know this is the Java in me coming out. But what this really does is it says, hey, if the factor count was 0, whatever number I'm on, I want it to say on the screen, blah is prime. 73 is prime. 74 is composite, 75 is composite, 76 is composite, 77 is composite, 78 is composite, 79 is prime. I wanted to say things like that. So that's what the num and the plus does. I'm assuming that's correct. Like, I don't think they actually define that in the curriculum, but I'm defining it right now. Plus sign joins text together. It adds text together. So that's my nested loop for primality checking. I'm going to repeat until I hit 1,000,000 all of these checks. Yuck. But hey, I got every single prime number from 3 to 1,000,000, or at least 3 to 999,999, right? Off by one thing. So your homework is going to be based on this. It's in Delta Math. Some of you have seen this stuff already. There's a quiz eventually on this stuff, but I don't really want to hammer you with a nested loop quiz right now. This is kind of brutal. So my goal is for you to watch both videos and then maybe do the programming lab and keep this stuff in the back of your head because it's going to be helpful later on when we start talking about it officially. So I hope your fall is going well. I hope your first quarter is going well, and I'll see everybody soon.